Okay, we're going to have a look here at dividing numbers that are raised to powers and how we would handle that. Let's have a look at an example. Put some numbers in here. Supposing we had 8, and we raised that to the power of 5. Well, you'll remember that means 8 times by itself, times by itself, times by 8 times 8, times 8 times 8 times 8. And we divided that by 8 to the power of 2. How do we handle that? Well, the easiest way to think about that initially is to write this out as a fraction. So 8 to the 5 is 8 times by 8 times by 8 times by 8 times by 8. 8 to the 5. And we're going to divide that by 8 squared, which is 8 times by 8. So we've got 8 to the 5 divided by 8 to the power of 2. We looked at cancelling in a previous video, and we can cancel here because if you notice we've got some 8s on the top and the bottom. We've got 8s up here in the numerator and the denominator, so we can cancel where we have an 8 in the numerator and the denominator. And we can do it again. So we've cancelled out 2 of our 8s and 2 of our 8s here, which actually leaves us with 8 times by 8 times by 8, which we know is 8 to the power of 3. Okay, well that's great. But what do we notice? If we come back to our original question and look at the powers, 8 to the power of 5, 8 to the power of 2, down here we've got 8 to the power of 3. We've actually subtracted the powers. So we've got down here is 8 to the power of 5 minus 2, which equals 8 to the power of 3. Okay. If we have a look at this in a more general case, we're going to use x now, just to widen this to a more general case. If we said, therefore, we had x to the power of 6, and we want to divide that by x to the power of 4. Okay? Just like we did here with numbers, we're going to do the same with algebra. X to the 6 just means x times by 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 x divided by x to the power of 4. There you go, x to the power of 4. So once again, we're going to cancel. We're going to cancel our x's. If we have 1 in the numerator and the denominator, we can cancel them like this. So actually, we're just left with x times x, which is x squared. And notice again, but what we've actually done is we've subtracted the powers. So we've ended up with x to the power of 6 minus 4, which is x squared. And it's useful to look at this longhand because once you understand this, then we can start to perhaps miss out this stage and just jump right to this approach. Let's look at an even more general case here. Suppose we had x to the power of n. And we want to divide that by x to the power of m. Okay, so I can't write this out longhand now, but I can jump straight to what we did here, which was that when we're dividing powers, dividing numbers raised to a power, we can subtract the powers. So we know, therefore, that that is going to be x to the power of n minus m. There is our most general way of looking at dividing numbers which are raised to a power. Let's put this into the context of the sort of question that you might see in an exam, the sort of question that you're going to have thrown at you. You remember from a previous video we looked at multiplying numbers raised to powers, as well as, and now we're going to include the dividing rules here. So let's put it all together in an example such as 4 squared multiplied by 4 to the power of 5. And we're going to divide all of that by, so I'm going to do it like that because I'm dividing all of that by 4 cubed. Okay. In the previous video, we saw that if we take a number raised to a power and multiply it by the same number raised to a different power, well, we can just add those powers. So, our first step here is to say that that is 4 to the power of 2 plus 5, which equals 4 to the power of 7, divided by 4 cubed. And we can now use what we've done here to handle this last step. 4 to the power of 7 divided by 4 cubed equals 4 to the power of 7 minus 3, which equals 4 to the power of 4. Normally you would leave your answer in index form as it is here, and that's how you would handle dividing numbers raised to different powers.
Okay, Mary, so let's have a look at this one. So solve x plus 2x equals 12. So what do you think you do first?
Okay, well, I want x on its own, so I would put x equals 12 minus 2x.
Okay, so a lot of the time we want to get x by itself, but what we want to do first is get all of these x's together. So can you see anything we can do with this? Get all these together in one place.
Oh, okay, it's 3x, isn't it?
Yeah,
so
absolutely.
3x equals 12. Oh, and so x equals 4.
Brilliant, spot on, well done.